Welcome to a new video. In this video, we will take a look at the domain of logarithms. In other words, which numbers make the logarithm function a valid function. We will take a look at these situations. For example, here, suppose that we have a function in this form, logarithm of g of x in f of x base. Here, the number that, or the function that we have here is g of x, and that g of x has to satisfy some requirements. For example, we all know that g of x has to be greater than 0. If we look at base here, which is f of x, okay, that f of x also has to be a positive real number. In other words, it has to be greater than 0. And we all know that the base cannot be equal to 1 in logarithms. So that means f of x can be an element of any positive real number except 1. And let's take a look at the first example that we have here. We are given f of x as logarithm of x minus 2 in base 5, and in this case, find the widest domain of this function. Okay, here we see that, if you compare it to the form that we have here, f of x is 5, and 5 is greater than 0, so the first condition is satisfied. And x minus 2, okay, which is g of x in our form, it has to be greater than 0 as well. So x minus 2 has to be greater than 0. And after this, we need to know how to solve inequalities. I'll make a separate video about this subject, but at the moment, I'll just solve the question as it is. So just send this negative 2 to the right side, okay? Here it was negative 2, and now it's going to be positive 2. X, that symbol is going to stay as it is. X is greater than positive 2. For the people who don't know how I send this, and then it was here negative, and now it becomes positive, I recommend you to take a look at my shortcuts videos. And for the next step, okay, from here, we can say that x is element of an interval from 2 to positive infinity. Why? Because x is greater than 2. That means x can be any number between those two numbers. And that 2 is not included. Why? Because there is no equal symbol. If it would be like x is greater than or equal to 2, then this is equal to, guys, in this case, I would write x is an element of an interval where the interval is between 2 and infinity. But in this case, x can be equal to 2. So that number is included. Let's take a look at our next question. And in this question also, we are asked to find the widest domain of this function. And again, we have to check the number and the basis for all logarithmic functions. If you look at the first term here, okay, the base is okay. Why? Because it is greater than 0. And for the second term, we have 3, which is okay as well. And now let's take a look at the numbers. In the first term, we have x minus 1. So x minus 1 has to be greater than 0. And from here, just send this negative 1 to the other side, okay, to make it positive. So from here, we have x is greater than 1. And now this is what we got from our first term. And now if you look at the second term here, okay, that value, which is 12 minus 2x, has to be greater than 0 as well. And now just send this negative 2x to the right side, okay? Or it doesn't matter, we can just send 12 to the other side, okay? If you do it, then we're going to have negative 2x greater than negative 12. Why? Because here it was positive 12, and now it becomes negative 12. And we need to leave x alone. How? Just divide both sides by negative 2. Negative 2. These are gone. Once we divide both sides in an inequality by a negative number, you have to switch, okay, that symbol. Here it was x is greater than, and now it becomes x is less than, guy. Okay, just switch its angle to the other side, okay? Or we can say switch its face to the other side. And if you divide negative 12 by negative 2, we have 6. So we have this, and from the first term, we have this. If you combine those, okay, x is in the middle, By using the first term, we have x is greater than 1. Okay, it has to be greater than 1. By using the second term, we have it is less than 6. So this is what we have. And how we can show it as an interval? This can be represented as this guy. So we can say that x is an element within this interval, 1 and 6. 1 and 6, they are not included in our solution. And let's continue with the next question. And again, in this question, we are asked to find the widest domain of this function. We need to make sure that the number and the base, they have to be greater than 0. Okay, so let's take a look at the number first. 7 minus x. 7 minus x has to be greater than 0. Just send this 7 to the right side to make it negative. So negative x is greater than negative 7. What we are looking for is positive x, not negative x. So to make this expression a positive x, we have to multiply both sides by negative 1. Okay, negative 1, and this side also negative 1. So negative 1 times negative x is positive x. If you multiply any inequality by a negative number, then you have to switch its side. Here it was greater than, and now it becomes less than. And negative 1 times negative 7 is positive 7. So what we got from here is, okay, x has to be less than 7, considering the number that we have here. Okay, but on considering the base term, okay, we can say that in x minus 3, that number has to be greater than 0 as well. So just send this negative 3 to the right side. Okay, so it's going to be x greater than 3. Okay, so what we have here, x has to be greater than 3. But what we have here, x is less than 7. So just put x in the middle, okay, which is less than 7. And the same x has to be greater than 3 as well. So solution set, we can say that, okay, x is an element of 3 and 7, numbers between 3 and 7, but we have to make sure that, you know, there is no any number which makes the base of the logarithm 1. If we look at here, if x is 4, okay, x 4 minus 3 makes the base 1. So from this interval, we have to exclude 1. That means minus, okay, let me write it here, minus 4. Okay, just let me write the whole expression here, okay. X is an element of this interval, which is 3 and 7, except 4. Okay, if I say x is an element of 4, 5, 6, these are single numbers. Okay, so that means x can be 4, 5, or 6. So that curly braces represents a single number actually. And that parentheses shows an interval. That's the difference between parentheses and the curly braces, and that's a different story that we will take a look at in functions. And let's take a look at the next question. And this is our last question in this video. Again, we have a function logarithm of 9 minus x squared, and the base is x minus 1, and in this case, what is the widest domain of this function? Again, we have to find the intervals here that makes the logarithm a valid logarithm. So let's start with the base first. So x minus 1 has to be greater than 0, guys. Just send this one to the right. So x is going to be greater than 1. And this is what we have by using the base. So by using the number, which is 9 minus x squared, okay? 9 minus x squared. And I need to find the roots of this x values, which makes this expression positive equal to the 0. And from here, 9 is the square of 3, okay, 3 square, and x is, of course, the square of 2. If you remember, there was a formula, okay, from algebraic equations. If a square minus b square, there exists such an expression, then we can factor this as a minus b times a plus b, okay? So if you say 3 squared minus x squared, then this, from the same logic, we can write this as 3 minus x times 3 plus, let me write it here, 3 minus x times 3 plus x is 0, guys. Okay, we have a multiplication and the result is 0. So from here, x, which x value makes this multiplication 0? 3. From here, negative 3 values makes this whole term, okay, 0. So we found that the roots of 9 minus x squared are 3 and negative 3. But is that all? No. We need to find an interval, as I said. How? Just let me make a table. Okay. Here we have 9 minus x squared function. And here we have x minus 1 function. And here we have the final part. Okay. So I need to write the roots. Here we have 1. Okay. Which x value makes this expression 0, 1. So I have 1 here, okay. I have 3 here and I have negative 3 here. So just let me write them here. I have from least to the greatest, I'll put them in order. Negative 3, 1, and positive 3. Okay, that one belongs to that function x minus 1. That negative 3 belongs to 9 minus x squared, and that positive 3 belongs to, again, 9 minus x squared. And by starting from the right side, okay, for this 9 minus x squared, write the sign which is in front of x squared. So because the sign which is in front of x squared is negative, I'm going to put here negative. Once you go next to the root, next to a single root, then change its sign. Here we have negative, and now we're going to have here positive, positive. And now we run into a new root, so we need to change our sign here also. Now it was positive, and now we're going to have negative. The same thing is applied here. For x minus 1 function, the sign which is in front of x is positive. So up to this root, I'm going to put positive, positive. Once I pass this root, I'm going to change the sign, negative, negative. In the final part, in both cases, we have to have positive value. That's what we're going to look for, okay? So we're going to have here negative. Okay, if you take the intersection, okay, we have to have positive in both places, okay, on both functions. Here we have positive for both. Here we don't have positive in both places. Here we don't have any positive. So this is what we have as a positive, okay? That means our x values, which are between 1 and 3, make both of these functions a positive value, okay? Those values make x minus 1 a positive value, and 9 times x squared a positive value as well. So I can say that, okay, x is an element of this interval. But let me write it first. So after you write this, then what we consider is, as I said before, okay, you need to make sure that if there is any number which makes the base 1, we have to exclude that number, okay? If we look at here, we have x minus 1, and if you put 2 instead of x, then we're going to have 1 as a base. So I have to exclude 2 from this interval, guys. So this is what I have as a result. Just let me write it at the top. X is an element of the interval where the interval is 1 and 3, but we have to exclude 2 from this interval. Why? Because 2 makes our base 1. I hope you liked the video, and hopefully see you in the upcoming videos.